Atoms are the fundamental building blocks of matter, consisting of three main types of subatomic particles: protons, neutrons, and electrons. These particles are arranged in a specific structure that defines the atom's chemical properties. Here is a detailed breakdown of the atomic structure. 1. Nucleus. At the core of the atom lies the nucleus, which contains two types of subatomic particles, protons and neutrons. The nucleus is extremely dense and occupies an exceedingly small portion of the atom's total volume, yet it contains all the atom's mass. Protons, P+. Protons are positively charged particles, each with a charge of +1 and a relative mass of 1 atomic mass unit, AMU. The number of protons in the nucleus determines the atomic number of the element, which defines the element's identity. For example, all atoms of hydrogen have 1 proton, while all atoms of carbon have 6 protons. Neutrons, N0. Neutrons are neutral particles, meaning they have no electric charge. They also have a mass close to 1 AMU. Neutrons contribute to the stability of the nucleus by preventing the repulsive forces between the positively charged protons from breaking the nucleus apart. The number of neutrons can vary between atoms of the same element, leading to different isotopes of that element. Together, the protons and neutrons make up the atomic mass of the atom, which is the total number of protons and neutrons. 2. Electron cloud. Surrounding the nucleus is the electron cloud, a region where electrons move around the nucleus in what are often described as orbitals. Unlike protons and neutrons, electrons have little mass, about 1/1836 the proton's mass, and carry a negative charge of -1. Despite their tiny mass, electrons play a crucial role in chemical reactions and bonding. Electrons, E-. Electrons are arranged in various energy levels or shells around the nucleus. The distribution of electrons across these levels follows certain rules, such as the Aufbau principle, Pauli exclusion principle, and Hund's rule. These rules help explain why electrons occupy specific orbitals at different energy levels. Energy levels and orbitals. Electrons exist at specific energy levels, also called shells, that are further divided into sublevels known as orbitals. Each energy level can hold a certain number of electrons. The first energy level, closest to the nucleus, contains a single s orbital, which can hold up to 2 electrons. The second energy level contains 1 s orbital, 2 electrons, and 3 p orbitals, each holding 2 electrons, for a total of 6. Higher energy levels contain additional orbitals, such as d orbitals, which can hold up to 10 electrons, and f orbitals, which can hold up to 14 electrons. The configuration of electrons in these orbitals determines how an atom interacts chemically with other atoms, as electrons in the outermost energy level, called valence electrons, are responsible for bonding. 3. Forces in the atom. Several fundamental forces act within the atom to maintain its structure. Electromagnetic force. This is the force of attraction between the positively charged protons in the nucleus and the negatively charged electrons in the electron cloud. It keeps the electrons bound to the nucleus. Strong nuclear force. This is a powerful force that holds protons and neutrons together in the nucleus, overcoming the repulsive forces between the positively charged protons. Weak nuclear force. This force is responsible for certain types of radioactive decay, such as beta decay, and affects the stability of the nucleus. 4. Isotopes and ions. Isotopes, atoms of the same element that differ in the number of neutrons, are called isotopes. For example, carbon-12 and carbon-14 are both isotopes of carbon, with 6 protons but different numbers of neutrons. Isotopes have the same chemical properties but different atomic masses. Ions. Atoms can gain or lose electrons, becoming charged particles known as ions. A positively charged ion, cation, forms when an atom loses electrons, while a negatively charged ion, anion, forms when an atom gains electrons. Ions are important in chemical reactions and bonding, particularly in the formation of ionic compounds. Summary of atomic structure. Nucleus contains protons, positive charge, and neutrons, neutral, accounting for all the atom's mass. Electron cloud surrounds the nucleus, contains electrons, negative charge, that occupy energy levels or orbitals, dictating the atom's chemical behavior. Forces. Electromagnetic forces hold electrons to the nucleus, while strong nuclear forces keep protons and neutrons bound in the nucleus. The arrangement of these components defines the identity, mass, and chemical properties of an atom, making the atomic structure the foundation for understanding chemistry and matter.